Yo, what is up, everybody? Welcome back. We're filming episode 106 today. Should be probably around a 2-hour video today, an hour and a half, like kind of what it usually is. But yeah, so we're gonna get into it. I've been doing a little bit of research on Linux. If anyone's watching this, I think I'm gonna switch to Linux this weekend. So that's pretty exciting. It just depends if I'm in town or not. I might be going to see some friends, so I don't know. I still haven't decided yet. But yeah, it could be a big switch. Switching to Linux. I have never taken a class on Linux before. I've used Linux on VMs before. I've also used it at an internship before, so I have maybe a little bit of experience with Linux, but I've never really used it as kind of like my daily OS, so this will be definitely a new experience. I've used a terminal before. I'm pretty comfortable with the terminal. But yeah, should be definitely a interesting time for the first, month or so having the operating system downloaded. So definitely gonna have to find a lot of different alternatives for Linux, a lot of different, I used to be a big gamer back in the day. Am I still a big gamer now? Maybe, but I play games here and there, so maybe I'd have to keep the dual boot Windows on here. I don't know, we'll see. But yeah, let's take a look at our Pokemon of the day. We got episode 106. We got a Hitmonlee today. Hitmonlee. Let's take a look at the sound. A Hitmonlee cry. There's our sound. We're going to take a look at some motivational quote of the day to get us going. Let's take a look. Here's a good one. Experience is a hard teacher because she gives you the test first, the lesson afterwards. Interesting. Pretty much saying experience, like kind of what I get from that is, you do it the first time, you learn from your mistakes, like it's like a test, you learn from your mistakes, and then you get the lesson afterwards because now you know how to do it. So pretty cool quote. But yeah, let's take a look at our problem of the day to get us started. Let's take a look at this problem. Is at least k times. You're given an integer array nums and a positive integer k. Return a number of subarrays with a maximum element of nums that appears at least k times in that subarray. A subarray is a continuous sequence of elements within an array. Okay. The subarrays that contain the element 3. Three, two, three. 3233 233 33. What do I think about this problem? So obviously the first step of this, we have to identify what the maximum value is here. I believe this is a sliding window problem. I'm gonna be honest with you, I'm gonna check. It is a sliding window problem. So we have that intuition, so we understand the sliding window problem. So I think our first step here is we got to identify, well, what is our maximum value, right? So I mean, there's many different ways we can identify the maximum value, right? We can loop through the for loop. We can use the max value. I think the easiest way is probably max val is equal to max of nums. I don't know if that will that do that. Oh, we didn't print it though. Print max val. Okay, we get 3. Okay, there we go. Okay. I think this is the easiest way in Python to find out max val, right? Okay, here, right, we want to go, okay, well, for I, we want to go, okay, for right in range length nums, right? Okay, we loop in the reach value. We want to keep looping. How do we want to do this, right? So we want to keep looping. When we see a value, if the dictionary is greater than or equal to 2, right? We obviously want to create our left value, right? So left is equal to 0. Okay. We go, okay, well, if we keep looping, our left is here, and we're here. One, 3, 2, 3. Then we go 1, 3, 2, 3, 3, and then we move 1 forward, right? We go left here, and we go. I think we want to go. We get here. We've added all the values, right? And we want to move our right pointer to our left, and then make our left here, and our right equal to left, and we go from here, and we run the sliding window, right? That's what I'm thinking. So we need some sort of dictionary, I think. Minus core dictionary. Equal to this, right? There we go. Okay, well. Trying to think here. My dictionary. Plus or equal to 1. Let's import the default dictionary. We want to use default dic int, right? We add our value here, right? Okay, and we go, well, while my underscore dic, we want our max val is greater than or equal to 2. Right? So we get here, right? Okay. We want to count this, right? So we needed some sort of count variable too. Count plus equal to 1. Okay. We need to add our count. Okay, go to our next value, right? Then our next iteration, we'll see that, right? Count plus equal to 1. Oh, okay. Increase cell count. If out of bounds, then we would go, okay, if right is greater than or equal to the length of nums minus 1, then we make left plus or equal to 1 and right equal to left. Get stuck in the infinite while. For right, add. Get stuck in the infinite while. Stuck in infinite while. Max val. Let me have a count here. -1. Freak plus or equal to 1, right? While my dictionary is greater than or equal to... Why do I have it hard-coded to? Jesus. What is greater than or equal to K? If out of bounds. If right is greater than nums -1. Right, minus or equal to 1. Trying to count. till we get here. One, while freak is greater than or equal to k. If numbers left is equal to max, while freak minus equal to 1. Well, it isn't, so left plus equal to 1. So now we're here, right? So we get to here. Our right is here. We get here. You see this value, right? Now we're at 323. We see this. Okay. Then We're at 233, then we see 33, which would be 4. Right. That's how we're getting 4. Somehow we need to be able to continue like this. Hey, your crewmate account, yeah, I know that. We know it was left, right, and Frank is created. For each valid subarray window at right, we do count plus equal to left. Okay, so we keep going while the... Okay, then we go here, 3, 2, 3, and then we go here, 2, 3, right? So we know that left is at 2, so we plus or equal to left, right? Then we go here, okay, and we know, okay, well, we would increase, right? So now we'd be at plus or equal to left, whoops. Now we'd be at here. Sorry, we'd be at here, and we know, okay, well, our left would be here, 3, 3. Then our left would be here. We'll go. Can't possibly go to left. Whoops. Okay. Okay, I understand. That's a hard trick to think about. I mean, I couldn't get this trick, but, you know, it's whatever. Let's try the... What would be the brute force approach here? The... is equal to max val. Maybe not actually, because j is going to start from 0 as well. So I guess nums j is equal to max val plus or equal to 1. Okay, if numbers j is equal to max val, we increase the count by 1. Okay, that's what I'm thinking, right? So we do whole this, right? Then we start from here, everything. Start from here, do everything. We go from here and do everything, right? If numbers j is equal to max val, we increase the count. Okay. Then we check, okay, well, if sorry, we increase our frequency, that's what I meant. Freq is equal to freq plus or equal to 1. If our frequency is greater than or equal to k, then we count, right? Let us get to the next value. Then our freq is 0 again. And our freq is equal to 0, right? We return our count. This would be 1. Okay. This should be 2. Sorry, no. This should be 1. Okay. This should be 2. Then we jump here. And we go, okay. This should be 1. Sorry, this should be 1. That's 3. Okay. This should be 4. And we jump here. This should be 1, 5. Then we jump here. This would be 6. All right, how's this wrong? We have to start from I. There we go. Just have to start from I. Right, well, overlapping repeater is always starting from 0, right? We want to start from I. So that's our brute force. I don't think it submits because this is all n squared. Yeah, okay. So we go to time mode. This is the brute force solution. That's why we have the sliding window, which is the O of n. How can we make this faster though? We can instead of doing it like this, how can we make this faster? Well, if our j is greater than or equal to k, right? Instead of getting those extra ones, we can do, okay, well, everything after k, technically if we get here, now everything after k should be included, right? So it'd be like break out of this loop. Will that work? Is this correct? is this technically... Will this submit? I don't know. No, it doesn't. I think we got a TLE. Yeah. Okay, anyway. I don't know if it can be any faster, but that other than the one that we did, but left maxi current 0 res for right. Maxi current plus equal to nums right is equal to maxi. Jesus, bro, what an explanation this is, man. Jesus, man, this guy's... What a Chad this guy is, man. Okay. That took a little bit longer than I thought, so that's okay. It's okay. I think we have done house rubber before. Doing some 1DP problems. We have done house rubber. It's been a while though. March 15th. About nearly a month and a bit ago, a month and a half. Your restaurant. Let's do this one again, then we'll go to something else. Professional rubber plenty number of houses on the street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is the adjacent house have security cameras. Security systems connected and it will automatically contact the police if 2 adjacent houses are broken into on the same night. You can arrange your numbers representing the amount of money of each house. Return the maximum amount of money you can rob tonight without alerting the police. I need some sort of like an array. Rubber house I. Some sort of like a some sort of like hash map or something. Okay, this is our base, right? Okay, we need our recursive case, right? Recursive with DP, right? We would go, okay, well, why is my knee just so cooked right now? Oh my god. Term as recursive with DP, right? So we use a dictionary and we store each of the so if we're at this I before, we know we always know that we're gonna go plus or equal to 2, I think, right? Because if we're at this I, we always know that we can't rob the adjacent, so we have to rob the next one. Equal to I don't know if this is the right way to do it. Doesn't seem right. House rubber 198. How do we do this solving with DP? I'm using a dictionary and saving each of the houses as we rob adjacent houses. Via a dictionary or a bottom-up via an array. Let's do count. trying to think here. I think this would be too slow running this every single time. Like, there has to be a better way to do it instead of this. Maybe like a custom with DP. We do like maybe we can do Rob House 0. Our count is 0, right? Start at I. We do like a. We can either like a rob or like a some sort of skip function, right? So we can like rob it and we can go, okay, well, rob it is equal to we do, okay, rob it. And we would call rob house. Nums I. Skip it, we would go skip it is equal to rob house I plus 1, right? Then we would get the max of these, right? So we go get the max. So it's equal to the max of rob it and skip it. Okay. And that's the one we skip. That's the one we stick with, right? All right, we'd have to go, okay, skip it. Well, rob it would be, I think, rob house I plus 2, right? We start with our count, so our count would then be count is equal to count, sorry, nums count, right? Nums I, whoops, I, right? So we get our count. We either rob it or we skip it, right? So I feel like I'm thinking about it correctly, right? We get our count is equal to nums I. Okay, we rob it or we skip it, right? I'm not sure, dude. I really don't know, actually. It's frustrating when you've done problems and you don't know how to do them anymore. Okay, I'm heading in the right direction. Key issues and fix receiver time value regressive calls. Okay, if we want to rob it, then I think our nums I would go here. Nums I plus. That makes more sense. Okay. Rob it, skip it, right? I plus 1, I plus 2, right? Oh, this is driving me insane, bro. Oh my god. My dictionary, I. If I. Okay. Rob it and skip it. Man, I was thinking about it right, dude, but I just couldn't. Row house I. Is equal to the max of rob it and skip it, right? Oh, we're not returning the right one. When I actually return the value, we're just returning the I. There we go. Okay. Tough, man. Rob it and skip it. Okay. On DP. Take a look at House Robert 2. Hey guys, 1 second. I'm gonna get a call in a second, so I'll be back after the call. I'm back. Yeah, I got some snacks. Sorry, I had to answer a call. Take a look here. I want to treat each house with a certain amount of money stashed. All houses placed are arranged in a circle. This means that the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected and will automatically contact the police if two adjacent houses are broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve House Robber 2. We already solved House Robber 1, and I would recommend watching that video, or at least solving that problem first before this one, because this one is very similar. So basically the premise of the problem is the same. We're just trying to maximize the amount that we can rob, and in this case we have a street, aka an array. So this is our array. We want to maximize the amount that we can rob. The only catch is that we can't rob two values that are adjacent to each other, because it's like two houses that are together. We can't rob two houses that are right next to each other. We have to choose one. So we can either choose the 2 or we can choose the 3, right? So that's basically House Robber 1. Now there's one more catch with this problem. In this case, the houses are actually arranged in a circle. So we have this as our array, but really this is what our array is going to look like. The 2 goes to the 3 goes to the 2, and then the 2 goes back to the 2, right? Basically what we're saying is this last value is also adjacent to the first value. So it's literally that simple. That's the only difference between House Robber 1 and House Robber 2. And actually, the good thing is you can reuse the solution from House Robber 1
That's
to
what I was
solve
thinking
this
too.
problem. And I'm going to show you how. So let's just remember House Robber 1 first of all, right? So we have this array, right? We can choose the houses we want to rob, but we just can't rob adjacent houses. So I'll explain at least a little bit about how we solved House Robber 1. Basically, it's kind of dynamic programming, and you can watch the first House Robber explanation if you want the basic, like the better explanation for it. But basically, okay, what's the max we can rob up until this point, right? That's 2, obviously, right? So we remember that. Okay, the max we can rob up to here is 2. Okay, what's the max we can rob up until here, right? Clearly, we have to make a choice. We can either rob 2, right, and then nothing from here, right? We don't rob here. And in that case, the max we could rob up until this point would be 2, but we know that rather than robbing house 2, right, we don't even carry this value forward, we just rob house 3, right? So then we can put a 3 here. So up until this point, the max we can rob is 3. Now, lastly, what's the max we can rob up until this point where we're looking at the entire array, right? Whatever value we put here is going to be our solution. So now we have 2 choices, right? We can rob house 2, skip 3, and then rob up until this point, right? And the value for here is 2, right? So 2 plus 2, we would get 4. Or we can make another choice. We can actually skip this house and just carry over the value that we computed before. What's the max we could rob from here, right? That's 3. We would just put the 3 here. Now, clearly, the first one that we computed was 4, so that's greater. The max we can rob for the entire array is 4. Now, I like House Robber 2 because it requires us to reuse the solution from House Robber 1 in a slightly clever way. It's not even about algorithms at this point. It's more about reusing the solution. It's about, you know, having a function. So the only restriction here, right, you see up here we robbed, like we were looking at, okay, what's the max we can rob from the entire array? The only restriction here is we can't use the same solution from here over here, right? The max we can rob from the first array is 4 with House Robber 1, but with this, if we rob this, skip this, and rob this. We're not allowed to do that because remember, the first and the last house is connected. Basically what I'm saying is if we rob house like the first house, we can't rob this one. Or if we rob this house, we can't rob this one. How can we reuse the solution from up here? Let me show you. Let's say this is our helper function, right? House robber 1. We can basically say, okay, we can run house robber 1 on the entire array except the last value, right? And what's that going to give us? It's going to give us a 2, right? We can also run the house robber 1 helper function on the entire array except the first value, and that would actually give us a max rob of 3. I think for this one it would also be a max rob of 3, right? But basically what I'm saying is we have to run the helper function twice on different subarrays of our input array because we're not allowed to rob the first and the last house together. So if you actually understand house robber 1, right, the helper function that we're going to use, and you understand what I'm saying over here, right, where we're not allowed to rob both the first and last house, then all you have to do is call the helper function twice on these two subarrays, and whatever one is the max is the value we're going to return. You can see in this case, from the first array, the max you can rob is 3, right, if you rob 3 and skip the first house, and if you from the second array, the exact same thing is true because this is a pretty symmetrical array. So if you skip house 2 and rob this one, this 3, you also get a max rob of 3. So that's going to be the solution. But it could have been different technically, right? Maybe this could have been a 5, right? And in that case, the max you could rob from the first subarray would be 5, skip the 3. So that.
Okay. Let's go back to house robber 1, grab our code. Okay, let's grab this. Ooh. Okay, so we have our rob house, right? Turn the max of rob house 0. Oh my god, I just instantly submitted it. Jesus. I don't think this will work, but I'm gonna try it. No, that didn't work. Rob house 2. Okay, that didn't work. Okay, let's get rid of that. Let me rewatch this.
We have to run the helper function twice on different subarrays of our input array because we're not allowed to rob the first and the last house together. So if you actually understand house robber 1, right, the helper function that we're going to use, and you understand what I'm saying over here, right, where we're not allowed to rob both the first and last house, then all you have to do is call the helper function twice on these two subarrays, and whatever one is the max is the value we're going to return. You can see.
Okay. Def Rob House I array. Okay. We would do okay. Is equal to, we want to go from slicing in Python. I always forget the inclusive, which is inclusive. The start index begins inclusive. Okay, so we start at 1, we go to the end. Right, so we would start 1, go to the end. At 1, go to the end, right? And our second array would be, okay, we start at here and we go to -1. Can we print first array? We print second array. Fuck me, dude. Okay, nums. Three, 2. Without the first one. 2, 3 without the last one. Okay, so that worked. Okay, so now we want to run this. We run, okay. First is equal to Rob House. Let's go 0 to, and we have first array. It's equal to Rob House 0 to second array, right? I guess actually we can just return the max of this. Return Rob House 0. And then Rob House 0 second array. Sorry. Array. For using the same dictionary. I didn't think that would make a difference. Oh, I guess we're doing it depending on the I. Right. Okay. Shit, well, I guess we're gonna have to pass in dictionary. Dictionary is not defined, bro. What? Oh no. Bro. Minus go dictionary. I guess we're gonna have to do minus go dictionary too. Oh, I guess we would have to pass in a dictionary, right? Because we wouldn't be able to reference it. Right, because I think 2. We can add a base case if the length of array is equal to 1, return ow. What the fuck, dude? If the length of nums is equal to 1, there we go. That's so funny. Nice. We did it. We did it. We did it. Hey. We did it. We did it. We did it. Hey. Let's check out this one. Longest palindromic string. Longest palindromic. Shit, we have done this one. This is question 5. When did we do this? Jan 29, 2025. Palindromic, substring, and S. Bab. Longest palindromic substring. Given S, return the longest palindromic substring in S. ABBA is also a valid answer. Bab. ABBA. Okay. BB. ABBA D. Bad. BB. Try to think what's the best way to solve this. I guess we go. How do we know if this is palindrome? Well, go here, then here, then here. Okay, let's just do like a function like is palindrome, def is palindrome. We pass in a left and a right pointer, right? Okay. We would call this like, okay, we would create our left is equal to 0. Our right is equal to the length of palindrome, the length of S minus 1. We would call this, okay, so while, oh shit. Okay, well, while left is less than right, we call this palindrome left, right. Here is palindrome, right? Then we want to take the height, take the length, right? Let's take the length, okay? Top length is equal to 0. If the length of let's do the is palindrome. Okay, so if while left is less than right, we want to check, okay, well, if s left does not equal s right, then we just want to return false. Otherwise, it is equal, then we go left plus or equal to 1, right minus or equal to 1. And we keep checking this return, then we return true. Then we know that's palindrome, okay? This is palindrome, right? Then we would take the length, okay? Take the length. We actually have to return the string. That's what makes it hard here. Okay, if we know that this is palindrome, if it's palindrome, then we can take the length, right? And then we call get array left right. So array is equal to get array left right. Okay, so let's do def get array. We do left right. Here we go. Okay, well for I in range length. For I in range left to right. Okay, we create an array. And we will go, okay, well, array array dot append I. We do that. We return our array. Okay. Well, that's this one, right? We do this array, and let's print our array. Shit, this is an infinite loop because we're doing a while here. Okay, so is palindrome. Okay, so it is palindrome. We get the array. Okay. Get the array. Okay. Then we get the length, right? We will do, okay, well, if the length of array is greater than, we want the top length, then let's make our res is equal to just like empty string or something. We make, okay, well, we make res is equal to dot join array. Then we do left plus or equal to 1, right minus or equal to 1. And then we just like return our res. Current code has multiple logical implementation issues. Okay, so our two pointer is shrinking while left is less than right. Doesn't explore all substrings. It only checks if it's causes a bug. You know, checking all substrings, only linear set of combinations. No special handling for single character strings or overlapping centers. Expand around center, left, right, non-local, res length, while equal to 0, greater than 0, and right is less. Oh, I'm appending integers indexes. Whoops. I'm sorry. B. Blah, 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 blah. I think we need to do right +1. Okay, this is obviously wrong. 8 out of 142 test cases passed. Okay, so we get A, output is this. Oh. Okay, so I'm checking a specific length, right? So I'm going checking this, and checking this, and checking this, right? I'm not actually checking, it could be this, right? It could be this. It could be this. Or it could be this, right? Left, right is pattern left, right. We're gonna get array. The length of the array. What's over? Res left, right, +1. Let's go. Okay, well, for I in range, for right in range length, right, range length S, sorry, is palindrome left, right, right? So we need to initialize our left here. Right, we'd have to do. Sorry, we have to go right for I in range length nums. Put J in range length nums. Okay. We'd have to check. Okay, well, we'd have to start from I here. So starting from I here, we check boom, 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 boom. Then we go here, check boom, 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 boom. J, get the array. If is palindrome, right? We call the is palindrome function, right? We check if it's palindrome. Okay, then we get the array, right? The size of 1. Okay, if left is equal to right. Then we just return true because it's obviously palindrome, right? If the size is 1, we would return true. If the length is equal to right, we would return true, right? We go through here, we'd append. J, the length, or right minus equal to 1. Bad. Sorry, I mean I and J. Geez, we declared left twice. We don't need that. See if this runs. It's probably too slow. I get a TLE. Okay, no we don't. I thought we handled this case, right? We would go in here. We would check, okay, well if left is equal to right, we would return true, right? Because we don't really need this get array function. Low key, I don't think. If the length of res is greater than top length, why does this not work now? We only get a size of 1. You never update top length. Okay. Whoops. Top length is equal to the length of array. Now we should get a TLE, I think. Right? Yeah, should get a TLE here. Okay, now we get a TLE. Okay. So this is brute force, right? Yes, your solution is brute force approach. Okay, right? This is brute force. Okay. If we want to do the dynamic programming here, we have to do a DP table, dynamic programming table. So how can we speed this up? Well, my solution using DP. But a 2D DP table with dij is true if the substring ij is a palindrome. all substrings like water, power drives, check all substrings. Yeah, to be honest, I'm not sure. How did I do it like this? Sliding window from center until valid. There's no way I did this. I definitely watched a video or something on this or got some sort of help. There's no way. So here I'm checking. Okay, no way. If N is 0, we will return empty string. We create the DP table. We have a start is equal to 0. The max length is 1. Well, substrings length 1 on power drive. Find range n if dpi is equal to true. Check all substrings of length greater than or equal to 2. For length in range 2 to n plus 1, length of substring. I in range n minus 1 plus 1, j is equal to I plus length minus 1. dpij is equal to false. If dpij and length is greater than max length, start I max length is equal to length. Return s start plus max length.
Illinois University, and today we're asking our students if they can name our 20.
Okay, for I, J, I. Substring.
If you want to learn Python for a career in data science, IT, or engineering, then you need the complete...
Hey everyone, let's solve another classic Leetcode problem today, longest palindromic substring. So we're given a string, in this case, BABAD, and we want to return the longest palindromic substring that exists inside of here. In this case, there's actually two, BAB as well as ABA. So we could return either of these and that would be perfectly fine. Now what actually is a palindromic substring in the first place? Basically it means that, you know, you take BAB, if we wrote that in the reverse order, which would be, you know, BAB, it's the exact same string. So like I usually do, let's say you just don't know how to solve the problem. Well, what's the most brute force way you could do it? Well, you could say, I'm just going to check every single substring in this original string and check if it's a palindrome and get the longest one. Starting at B, so I would check this, I could check this, I could check this, this, and this, right? So every substring containing this original B. And I want to check for each of these, is it a palindrome or not? And I would repeat that process with every character, right? So for this A, I'd get every substring and basically keep doing that. Now, the question is, for a string, for example, B, I'm gonna initialize the result, which is in, as well as while this is a palindrome, so I want to check that the left and right are equal to each other. Remember, we're starting in the middle and expanding outwards. So while this is the case, we know it's a palindrome, so we can potentially update our result. So we'll check that the length of this palindrome, which we can compute by saying right minus left plus 1, is greater than our current result length, then we update the result. And we also have to not forget to update the result length. I usually forget to do this. And let's also not forget to expand our pointers outward. So our left pointer will be shifted to the left. Our right pointer will be shifted to the right. So now let's check the even length palindromes as well. Right now, you can handle this a bunch of different ways. The way I'm going to do it is setting the left pointer to I and setting the right pointer to I plus 1. So again, we're basically copy and pasting the code that we just wrote above. Maybe we could write a function to do this, but I'm too lazy to do that. So while it's a palindrome again, we'll check that the length is, we'll check that it's the longest palindrome that we've seen so far, basically. If it is, we update our result. For me, putting the if statement,
He's not using DP on that one though. Oh, this is house robber. I want longest palindromic string.
Hey everyone, let's solve another classic Leetcode problem today, longest palindromic substring. So we're considering it to be the center. So first, right now, you can...
Two dynamic programming. 2 pointers. Two pointers. This is pretty much the one that I did, in a way. Mine's n squared, I think. Brute force. So we're putting false. What's the length of S? For in range length S. TPII is equal to true. Let me get rid of all this really quick. Okay. All right, length 1 is this one is true, right? So here we can then get rid of this is palindrome function, right? Length in range, we start from 2, go to the length of S plus 1. Of S minus the length plus 1. I plus length minus 1. If SI is equal to SJ, and if length is equal to 2, DPI J is equal to true, else DPI J bro, this code is hard to understand. Oh my gosh. Man, that is confusing as hell, dude. In range n minus 1, we start at minus 1, minus 1. So we're running backwards for j and I and n. I don't like this solution here. Okay, I want to study this code. This looks a little bit easier to read. Right, let's just make sure this runs. Okay, we have res index and res length is 0. We got the length of S. We create our DP array, 2D array, right? Okay, we go from I, we start from the last value, right? And then our J out in a loop here starts from I and goes till N. If Si is equal to Sj and J minus I J minus I is less than or equal to 2. I think we're checking if it's less than or equal to 2 because 2 or 1 would be the same, right? It's a small substring, 1 to 2, or the inside substring is really known to be a palindrome. Oh my god, dude. Okay. We're going to come back to this problem again. I mean, we already solved it a different way. I think I'm going to take a look at a dynamic programming video on Python to get some background, I think. God, but I don't want a 2-hour video, bro. Like, do we really need Python 1D? Full course.
Hey everyone, welcome back, and let's write.
You recognize the problem is indeed a DP problem. Let's do a dynamic programming course or something.
Before I understood what nuclear truly meant, before I could use my mind to move a submarine, I had to be born for it.
This is Google Pixel 9a with
Bro,
Gemini.
so many
It's free
ads,
at
man.
Verizon,
Oh my god.
with plans starting at $30 a line. And this is Nicole asking, where the heck are you? And Gemini helping you respond in the style of Shakespeare. Get Google Pixel 9a on us and our new 3-year price lock guarantee with plans starting at $30 a line.
Poof, 5 hours, dude. Jeez,
Hey
man.
programmers, I'm Alvin. Welcome to our course.
Okay, we're gonna leave it at that. I might take a look at this course. I think we looked at this guy for graphs, so I guess we just gotta keep going, man. We just gotta keep doing problems, keep getting better, like just the way it is. So appreciate you guys watching, and I will see you tomorrow.